let us begin to tighten the screw on the tent. No, you have not misheard. Did you know that stan in Czech means tent? So, PHPStan means PHP tent. What's more, the lecture leaves no illusions either. We will be tuning it to the maximum strictness. In a word, we will be tightening the screw on it and by the hands of the father of this project. Besides the traditional rule levels from 0 through 9, which allow developers to adopt PHPStan incrementally while gradually increasing strictness, the static analyzer offers plenty of other configuration options for looking at the code with a critical eye. Now, Ondřej Mirtes will show us these options with examples of their practical impact on the code, which will become more predictable and readable. Fantastic! Let's listen then.
Hello everyone, I'm happy to be back in the land of The Witcher and Cyberpunk again. And I'm here today because I like pointing out mistakes in other people's code so much that I created a static analyzer that does it for me. So, who already uses PHPStan? Yeah, almost everyone. That's always awesome to see. So, for those who are not familiar, here's a short introduction. And what is PHPStan? It's basically the missing compiler for PHP, because my initial inspiration for creating PHPStan was Java, because I was forced to work with Java at the university, and I was a PHP developer already at the time. I was missing some parts from PHP in Java and some parts from Java in PHP, namely the compiler, because the compiler in the compiled language does not let you run an application with obvious mistakes like accessing an undefined variable or calling an undefined method. It's not the application will not run at all. You are not going to be able to deploy it. But on the other hand, PHP is interpreted, so it's completely different. PHP will happily run your application for you, but when you have some kind of grave mistake, like accessing an undefined variable, it's not even going to crash, right? It's just going to generate a notice. But you really shouldn't have these mistakes in your code, so PHPStan is going to look for them, and you will have to spend a lot less time finding these mistakes manually or with tests in your code. So without static analysis, without PHPStan, PHP developers spend a lot of time uncovering mistakes that wouldn't even compile with other languages, but PHPStan is going to scan your whole code base and is going to find these bugs for you. This is how the output can look like. We can see that our test script has 2 mistakes. Some method is promising to return a string, but instead it returns an integer. And also we've made a typo when calling method getMessage So PHPStan is able to find mistakes like these. When talking about PHPStan, we of course have to talk about rule levels. So rule levels are a concept how you can gradually introduce PHPStan into your workflow, into your code base. So the inspiration for rule levels was the fact that when I first worked on PHPStan, I always implemented a single rule. Then I tried it on a company's code base where I worked at the time. I fixed all those mistakes found by this single rule. I merged those bug fixes, and then I moved on and I implemented another rule in PHPStan. But right now, after, well, 8 years of development, PHPStan is already pretty capable. So if I showed you everything that's wrong with your code at once, it would output thousands and thousands of errors, and you would quickly get discouraged, and you would uninstall it, and you would never see it again, right? So rule levels will kind of let you slowly dip into the waters of static analysis, and on level 0 you will only see the basic mistakes that are definitely errors, like calling an undefined function or referencing an unknown class and so on. Errors on level 0 might also mean that you have to spend some time configuring PHPStan so it can find all your classes that or all functions that you are using. And once you have 0 errors on level 0, you should merge PHPStan into your main branch. You should start using it in CI, and you should also get used to run it on every commit. So the higher the level, the more errors will PHPStan report to you. And the big question is, which level should you use in the end? Like when you should stop. I will not go into much detail what happens on each level between 0 and 5, because everything you need to know is that on level 5, all the basic bugs are checked. Your application will mostly work, and all the most grave mistakes that you can have in your code are going to be reported on level 5. Level 6 is about missing type hints. So PHPStan forces you to add type hints to your parameters and return types, and it also wants you to find arrays that if you are typing an array, PHPStan wants you to say what's in your array. So that's also enforced on level 6. And the idea is that without types, PHPStan cannot work. So theoretically, if this level was not in there, you would be able to achieve the highest level in PHPStan just by removing all the type hints. But I'm not giving you the ideas how to do it. Instead, you should go through your code base and add all the type hints so that, for one, you are documenting the code so that other people know how to call it, and you are also informing static analyzer so that this information is machine readable and you know what's going on in your methods and what they accept and what they return. Level 7 is about partially wrong unions. So what it means, let's say that we have 2 interfaces, and only one of those interfaces have a method called doBar. And let's say that we type hint a union of those 2 interfaces, or maybe we are calling a method that's returning a union of these 2 interfaces, and we are calling the method that's present only on one of those interfaces. And up until level 6, this isn't an error in PHPStan. Only on level 7, this partially wrong code, this partially wrong union is reported. And the reason why it's not reported sooner, because sometimes it might be hard to get rid of these bugs in your legacy application. Because in practice, you might know in your head as a developer, if you are familiar with your code base, is that this place might only ever be called with the right interface, but the type hint does not say so. So PHPStan doesn't know this information, that's only in your brain. So that's why this is only reported on level 7. And you need to make it obvious to the static analyzer that what's going on. So by fixing the type hint, or maybe by adding the method on the other type as well. Level 8 is similar, but it's about nullables. So let's say that we have a single interface, we have interface bar, and we have parameter that's either bar or null. So up until level 7, this is not reported as an error, but on level 8, you get this error that you might be calling a method on a null, which is going to crash in PHP. And last but not least, currently there are 10 levels from 0 to 9, so the highest level is about being stricter about mixed. So until level 8, you can do what you want with the mixed type. PHPStan does not check anything on it, so it considers the code that uses mixed correct. And it's not exactly safe, right? Like mixed can be anything. So on level 9, this is checked. So the only safe thing that you can do with mixed is to pass it as a parameter or return it to another mixed, because all other operations might be unsafe, right? You can't call a method on mixed, you can't add 2 mixed together, because it might result in some kind of error in PHP. But level 9 is really brutal because in practice, in PHP applications, a lot of stuff is mixed, right? If we are decoding JSON, if we are unserializing data from disk, a lot of stuff is mixed. So you don't need to feel obligated to use level 9, because I'm going to tell you a little interesting fact that not even PHPStan itself is using level 9. PHPStan itself is analyzed using level 8, and I don't plan to increase it. So I will say that about the question, what level should you use? So over time, you should strive for at least level 5. And then you can feel free to add type hints into your code, which means that you will pass level 6, and then you will run level 7, and you will see how much more work you need to do. Okay, so in all of my presentations, I strive for the audience, for people to be able to go back to work on Monday and to be able to apply something they learned during my presentation. So you can enable any option that I will be talking about today, or you can increase your level, because PHPStan lets you cheat. And PHPStan lets you cheat using the baseline. Who uses the baseline? Okay, a few people. And the baseline basically lets you say, let's say that we have 500 errors after installing PHPStan, or after increasing the level, or after enabling some new rule. And the baseline lets you generate a config file that will ignore these 500 errors. And it means that these 500 errors become part of the baseline. And then if we introduce 10 new errors, so we have 510 errors, the PHPStan will filter the errors from the baseline, and we will see only the 10 new errors. So this concept can be used in several creative ways. So let's say that you have 0 errors on level 5, and you increase to level 6, and then you generate the baseline, which means that missing time hints will only be enforced to be added in new and changed code. Or you might like some idea for a custom rule, or you will enable an option that one of the options that I will be talking about today. But this option will report many new violations in your code base, so you can add them to the baseline, and it will enforce this rule only in new and changed code. So yeah, that's the idea. So you are never blocked from doing something new with PHPStan, because you can always baseline the existing errors. All right, so I talked about levels, I talked about the baseline, and now finally, let's do something extra on top of the highest level. So the first strict thing I want to be talking about today are strict rules. Who uses strict rules already? Okay. These rules are more opinionated. PHPStan out of the box reports objective bugs that will cause some kind of problems, some kind of errors in every PHP application. But strict rules are more opinionated. They are about how code should look like, to be written a little bit more defensively, a little bit more safely, but some people might definitely not like what strict rules enforce them to do. So that's why it's an extra package, and it's not enabled by default, and it's not part of any core level in PHPStan itself. So one point of the package is to change the defaults of options that are already present in PHPStan. So if you actually look at how the package configuration looks like in strict rules, you will see that one part only enables parameters that are already present in PHPStan itself. So if you like the behavior of some of these, you don't have to install this package at all. You can just go into your project configuration in phpstan.neon, and you can change these parameters. But the second part of this package is, of course, some new extra custom rules. So one example that PHPStan strict rules do is that they enforce only booleans in conditions. So let's say that our function accepts a parameter with type string or null, and then we can see that the developer wrote if $s. And from this code, we have no idea what the developer meant by this. Did they want to eliminate null? Did they want to eliminate empty strings? Did they want to eliminate also some other values that are not obvious, but PHP considers them falsy? We don't know. So you might not realize, but if you look at these examples, you can see that most of these strings are cast to true, but string that consists of a single zero is cast to false. So this is not a good way to, for example, eliminate null and empty strings, because there's an empty string that's actually falsy. So it's not a good idea to do it. So what I mean by only booleans in conditions is that the developer should write specifically and explicitly what they mean to eliminate with their condition. So if I want to eliminate null and I want to eliminate an empty string, I should say so explicitly with my code. This code is longer, but is free of any bugs as far as I'm concerned. And for similar reasons, PHPStan strict rules will not allow you to use empty in your code. So if you see what empty is equivalent to, it means that the thing in the parentheses is not set, or the thing in the parentheses is equal to false using two equal signs. And two equal signs is full of gotchas. So if you look at this table in PHP documentation, it's a completely random mess. That's not memorable, that's not predictable, and you should stay away far from this as possible. And instead, you should use three equal signs everywhere in your code, which means you also not should use empty, which uses two equal signs. So with three equal signs, it's predictable and it's obvious. So only the things on the diagonal where the type is the same are going to be true, and everything else is going to be false. And PHP's strict rules also force a strict flag in some functions like inArray or array search, because this basically switches the behavior from the two equal signs semantics to three equal signs semantics. So instead of doing inArray like this, you should do it like this. Another thing that makes it closer to compiled languages is that you should not use loop variables outside of loops. So this applies to for loop and for each loop. And it means that even if we are sure that this for each is going to run at least once, it means that we cannot use the variable below the for each. So by default, out of the box, PHPStan does not report this as a bug, because we know that it's a non-empty array, we know that it's going to run at least once, and we know that below the for each, the variable is going to be defined and it's going to contain the last element in the array. But when you look at this code in practice, you don't know if the developer intended to access the last variable, the last array element like this, or if it's a mistake and they wanted to access a different variable. So strict rules are going to report this as possibly undefined variable, and they will force you to rewrite this code in a different way. PHPStan strict rules also disallow dynamic code. So you can do a lot of stuff in PHP dynamically, which means that if you do $$ some variable, it means that we are going to access a variable that's as a string name inside the $s variable, which is really dynamic code, and in the end we don't know what variable is going to be accessed and if it exists. And we can also access properties like this, and we can access methods. We can call methods like this, which is really dangerous because we don't know that the method exists, we don't know if it's public, we don't know if it has any required arguments, we don't know the type of the parameters. So this code is really dangerous, and static analyzer cannot reason about this code. So PHP strict rules disallow this, and it wants you to rewrite this code to be less dynamic, to be more predictable and obvious what's going on. PHP strict rules also want you to call a parent constructor in a class. So object encapsulation is an important concept, and usually people think about it in terms of not being able to break an object, which means that we don't have public properties, we only have private properties, so no one can change the state of the object as they want to, and we only have public methods which, before they do something to the object, before they mutate it, they check if you even can do the thing that you want to do. And but extending a class is also a form of using an object, a class, right? So when you are creating a new class, when you are developing it, you usually want to rely on the constructor being called right before, because you might require some arguments, or you might set some initial state of the object. So PHP strict rules always want you to call the parent constructor. All right. There are even some more stricter options in PHPStan that are not part of any level, and they are not part of PHP strict rules package. And you can read them in the documentation if you follow these breadcrumbs. So you can go to phpstan.org, you can go to documentation, config references, strict analysis, and I will be talking about some of these options right now. So one of them is check uninitialized properties. And this is not enabled by default because it might be a little bit too opinionated, but what it does is that when I have a typed property and I don't set it in the constructor, it's not really safe to call the getter, right? Because if we create a new object and we first call the getter, PHP is going to throw some error about accessing an uninitialized property. So this code is unsafe if we first go to call the getter before calling the setter. But I realize that this is a little bit too opinionated, because some code that looks like this might be completely fine, right? Because we might know that someone called the setter after that, someone must call the setter before calling the getter, or that the object is actually constructed by some DI container with auto-wiring and so on, and this code might actually be fine. But you can turn check uninitialized properties to true and code that classes that contain these properties that are not set in the constructor are going to be reported as an error. And I am running a little experiment here, and PHP 8.1 added read-only properties. And PHP itself doesn't require them to be assigned in the constructor, but PHPStan does. Even if you have check uninitialized properties set to false, PHPStan is going to report an error that you haven't set a read-only property in the constructor. Some people complain about it, but so far I'm holding the line and I'm keeping this behavior in, because I'm assuming that when you are declaring read-only properties, you are probably implementing an immutable object. So I think it's a good idea to enforce this. And another option that I want to talk about is reporting possibly non-existent offsets. So these options are quite new in PHPStan, and there's a couple of them, and one of them is for general arrays, and the other one is for constant arrays. So also constant arrays are also known as array shapes. So this is a general array. And PHPStan already, out of the box, without setting any extra option, already reports offsets that are always undefined, always non-existent. So for example, if you inject in an array that has integer keys, and you try to access a string key on this array, PHPStan is always going to report it. But in this case, this offset might be defined or it might not be defined. So this is going to be reported as an error if you set the first option to true. And if you set the second option to true, the same is going to happen for constant arrays, also for array shapes. So this offset might also be possibly defined or possibly not. In my experience, this behavior might be a little bit annoying, so that's why it's not turned on out of the box. But if you turn it on and you find it useful, you are supposed to always check for the existence of an offset before you access it. So you can use isSet keyword, or you can use array key exists function. All right. If you already use level 9, who already uses level 9? And it's not enough for you, and you want even more strictness and even more nightmares, you can turn on level 9 on steroids, which is going to report this problem, which is going to be stricter about mixed, which is going to report this problem in more situations. And a little spoiler for you, this level 9 on steroids is actually going to become level 10 in PHPStan 2.0. So there's going to be a new max level, and it's going to mean that this option is set to true. So what does it do? Level 9 is about explicit mixed in your code, and this option is about implicit mixed in your code. So in the first example, at the top, this is reported on level 9 because the mixed type is present. And if the mixed type is missing, and somehow you might have ignored it on level 6 when PHPStan wanted you to add this this type hint. So if you are missing the type completely, or maybe you are calling some third-party library that is completely missing types, it's going to be reported also as a violation, as an error. So basically, you will get more errors. And the experience might vary in different projects. So some projects might not see any difference when this is set to true, but from my testing, from one example, one of the projects I have access to has something like 9,000 errors on level 9, and setting this to true, they will have something like 10,000 errors more. So there's some practical difference between setting this to true or not. All right. Another important concept is a benevolent union type. So I try to design PHPStan not to be too annoying. So you might not feel the same way, but I really try to do that. And one concept that helps me with it is a benevolent union type. So let's say that we have an array with an unknown key type. It's just typed as an array of strings. And so the key might be an integer, or it might be a string. And out of the box, PHPStan is not going to complain if you pass this benevolent union key type to a parameter that requires an integer, or if you pass it to a parameter that requires a string. PHPStan is completely fine with this because it might be an integer or it might be a string. And if the developer is doing this, they probably know what they are doing. So this is not reported out of the box. But if you explicitly say that the type is an integer or a string, in the second example, if you specifically type this key type and you try to pass it to a more narrow type, like an integer, it's going to be reported. But if you set check benevolent union types to true, even the first example is going to be reported as an error, because you are saying, I don't care about the benevolency of these union types, and I always want this to be reported. And again, if you try this, you will see how annoying it is, and why am I probably right that it's off by default. All right, next topic is a little bit bigger one, and it will go over multiple screens, multiple slides. So consider this code. We are asking if person get name is not null, and then we are outputting the name. So the person who wrote this code relies on the fact that getName is always going to return the same value. And I'm not holding it against them because they are probably right. So by default, PHPStan inside the if statement considers the getter call as not nullable. PHPStan is going to remember that you've already that you have already checked what's in the getter, and it's not going to complain that it might be null. And this is a concept that's called function purity. So by default, PHPStan considers this getter to be pure. And pure means that it's going to return the same value with the same input. And input is the object state, and it's also the function arguments. And pure function should not have any side effects. So pure function shouldn't sleep, pure function shouldn't access the file system, shouldn't access pure function shouldn't be printing anything, and pure function shouldn't generate random values, and shouldn't depend on time. It should be deterministic, it should be pure. So in this case, this behavior is natural, right? It's expected, and it helps PHPStan to be less annoying. But in other situations, it makes PHPStan more annoying. So let's say that we are writing a unit test, and we checked that person getName is null, and then we call setter, and PHPStan, after calling the setter, might still think that person getName is null, because we already checked it, right? So in some situations, the default out-of-the-box behavior is helpful, and in some other situations, it's more annoying. So somehow we need to solve this, and it's going to require a little bit work from your side. So the default behavior looks like this. Functions and methods that return a value are considered pure, which means that if you call it a second time, PHPStan will think that it returns the same thing. Functions and methods that return void are considered impure, and constructors are pure, which means that if you pass some objects into the constructor, PHPStan is not going to reset their state. And if you call an impure method on an object, it's going to forget the state of the object. So this means that this actually is not going to be reported as an error if setName returns void, because setName is going to forget the state of the object, and PHPStan, after calling the setter, will think that getName can return string or null because it forgot the remembered state of the object. All right, so these are the defaults, and we might want to override them. So you can do it on one-on-one basis, and if you have something that looks like a getter and it returns a value, but in fact it's non-deterministic, it's not pure, you can mark it as PHPStan impure, and it means that if you then call it for a second time, PHPStan is not going to remember what it was previously. So if you mark it as impure in this case, and you call it as an if condition, and then you call it again inside the if branch, it's still going to be nullable. All right, if you don't want to put a lot of these annotations, a lot of these PHPStan impure PHP tags in your code, you can change the default behavior. And it's actually the stricter option, right? Because if you think about it, this is it's like the most of our code looks like, but in practice it might be unsafe and it might be wrong, right? So if you want to be more strict, which this presentation is about, you can set remember possibly impure function values to false, and it means that by default, without any kind of annotation, the getter is going to be considered impure, and it's still going to, PHPStan will still think that inside the if statement, the getter is possibly going to return null. So if you want to be more strict, you should set remember possibly impure function values to false. Oof. And you can also, once you set this to false, you can also obtain to the other behavior, right? So when we have this set to false, but you know for a fact that some of your getters are pure, you can mark them as pure at PHPStan pure, and you will return back to the original, to the default behavior for the functions that you opted them into this behavior with PHPStan pure. So if we have this set to false, and we mark this getter as pure, and we call it a second time, PHPStan will remember what it returned the first time. Okay, everybody gets it? Okay, awesome. So, another topic is something called bleeding catch. Is someone running PHPStan with bleeding catch enabled? Okay, that's more than 0. That's awesome. So the idea with bleeding catch is that I don't work on a new major PHPStan version in a separate branch, because I don't want to get into conflicts. I don't want to maintain a separate branch for a long time. So instead, the code that belongs to the next major version is shipped inside the current stable version that's currently living on your computers. But this new behavior is behind feature toggles, and it's off by default. So including this configuration file is a way for you to enable new rules and behavior and get them before everyone else gets them in PHPStan 2.0. And the point of this is also to get feedback really easily and be able to quickly polish those new features for the rest of the users that will get them enabled by default and not be able to turn them off in PHPStan 2.0. So if you opt into this, your build will definitely fail more often, but you will basically live ahead of everyone else and in the future. So what's there not to like, right? And once you do this and you kind of catch up with the latest features and changes, the upgrade to the next major version for you will be much easier, because basically PHPStan 2.0 is going to be PHPStan 1.12 plus bleeding edge plus some minor BC breaks. So you can basically get 2.0 today if you just enable this configuration option and see what new stuff it reports and enables. One of examples what it does is that the list type is enforced. So we've implemented support for list type at some point in the 1.x series of PHPStan, and the idea behind it is it's stricter array. So in other languages, arrays and lists are different types. And list, in this case, is an array indexed from 0 and without any gaps between the indexes. So you know that if when an array has, for example, 10 items, you know that it's going to be indexed from 0 to 9 in case it's a list. So if you enable bleeding catch, PHPStan will start complaining that you are passing if you have this type in your code, that you are passing something that isn't a list into these parameters, into these types. Another example of a new rule in PHPStan with bleeding catch is detecting wrong inline vartags. So I'm really unhappy about inline vartags, and I would like to see them eliminated, because people use them for many different purposes, like narrowing the return type, or fixing wrong third-party PHP docs, or telling the ID what's in the variable. And because of these different use cases, PHPStan cannot report any error about these inline vartags. But I realized there's one narrow situation where I can report when there's something wrong with this inline vartag. And it's precisely this. If you are assigning something on the right side that has a native return type, and you are basically casting it with an inline vartag to something that's wider than the native return type, I can definitely report that you are wrong, right? Because this can never be null. This can only ever be a string. So if you enable bleeding edge, you will see these kinds of errors in your code. And bleeding edge is not only about new rules, it's also about possibility to do BC breaks if you enable bleeding edge. And because I was able to do small BC breaks that might impact some custom rules, I was able to break some memory reference cycles between objects at a cost of a small BC break. And because I did that, when running PHPStan, the garbage collector is not doing anything. It doesn't need to do anything because there are no more reference cycles, so it doesn't have anything to do, and which means that in some cases, on some large projects, it might be a lot faster. So in this example, when analyzing open source solution for e-commerce PrestaShop 8, if I analyze it in GitHub Actions, without bleeding edge, it finishes in about 10 minutes, and with bleeding edge, it finishes in about 3 minutes. But of course, it doesn't mean that PHPStan is faster 3 times for everyone. It just means that in this specific case, on 2 parallel workers, it's going to finish in a third of the time. But your experience might vary. All right. You can also look into more extensions, more packages that can enhance what PHPStan reports for you. And if you look at the extension library, you might find many gems that might be really useful for you. So if you are using some framework like Doctrine or Symfony, and definitely everyone is writing unit tests, so they are using PHP unit, right? So you can install these framework-specific extensions to get, on one hand, you will get less false positives because PHPStan is going to understand your framework-specific code better. But on the other hand, you will also get some new framework-specific rules. And you can also look into third-party rules. So a company called Chipmunk is doing a lot of awesome work. So you should definitely check out their PHPStan rules and also their new project called Dead Code Detector, which understands what classes and what functions in your project are used and unused. So after running it, you might be able to delete a lot of code. And you can also check out packages from Markus Stab, who is a very active contributor to PHPStan and also has some custom rules. And if you want to look for even more rules, you can check out Packagist by searching for PHPStan, and then you can select package type PHPStan extension in the right sidebar, and you will see many more extensions that you might be able to use in your project. You can also write your own custom rules. So it's really you can write custom rules about specific issues that are specific to your code base, and once you start, it's really addicting. So more and more people are doing that. And you can start by reading the documentation on phpstan.org. You should always use the latest version, so make sure you are on the latest version with some automated process by using dependabot or a renovatebot. And this is my full-time job, so you can sponsor me on GitHub sponsors. And I have one more thing. This little guy right here. So there is going to be a PHPStan elephant. There is only one of them. This is a prototype. And I want to release it. I want to start selling it alongside PHPStan 2.0, which is going to be released next month in November. And once the release is out, you will be able to order it. And if you don't want to, if you want to remember that there is going to be an elephant, you can sign up for the newsletter, and you will be notified when PHPStan 2.0 is out and the elephant is available to be bought. Okay, that's everything from me today. Please rate my talk on Joined-in. And if you want some PHPStan stickers, they are here on the stage. So thank you very much. Do you have any questions?
Hi, thank you for this amazing tool. I love it. I use it all the time. I have several questions. I think for me, this is quite a curious thing. How do you decide whether some of the rules that you said that are opinionated or like on the bleeding edge should go back to the core? I mean, like should go to core because everyone is saying, okay, this is good. We should have it.
Yeah, it's basically my hunch. And it already happened a couple of times or several times that we added something to bleeding edge, and the few people that used bleeding edge didn't like the rule, so we removed it again. So that's the point behind bleeding edge. You are an early adopter, and you can give feedback about what should be in the project. Yeah, but before the feedback, before the process, it's about my hunch. So right now. PHPStan 2.0 is almost ready, and there is one rule that was added to bleeding edge, but I'm not sure if it's going to stay in. So it's a new rule from a contributor that looks at your require once, include once statements, and looks at if the file in the statement exists. And sometimes people are complaining that they are referencing a file on their disk that isn't there when they are analyzing the project, but it's going to be there in production. So I don't know.
Yeah,
and at the same time, I cannot like remove this error when you are asking if you have this require statement inside an if condition. So if you ask if is this a file, or if file exists, then require it, because this is not atomic, right? It's like two different points in time, and the file might be removed between the isFile call and the require call. So it's a tough.
I think I reported something similar to that, because the state of the variable was switched in another call of the method, and it was not possible to be detected. Anyway, thank you. I'm looking forward to this. Next question. You said about the pure and impure methods, and for the setters, it was said that it will be only for the ones that are returning void. Why not void and self?
Yeah, I think I added, based on the last time I gave this presentation, I added, besides void, I'm also doing it for static, because you are probably like returning the same thing. You are probably doing something to the object if you are returning static, right? Or you are returning this. So it's not done for self, but it's done for static and this, I think. Right
okay,
yeah.
So it's like this just being required to be there, right? It's not like, oh, okay, I understand that. And last thing, I have a problem with like level 9. I would like to use it all the time, but for example, when using Symfony and Doctrine, especially like writing or the query builders in repository file, for version 9, even with PHPStan Doctrine extension, I had to just add like the result of the query builder call had to be like moved to a separate variable. With the var type. I don't like it as well, and then just return it.
Even if you install PHPStan Doctrine, you still need to provide the object manager loader. You basically need to give your own entity manager instance to PHPStan so that it can infer the result, the types of these results. So make sure you are doing that.
Oh, okay, so it's like configurable or something.
You still need to add some configuration so that it works for you, because PHPStan needs to see what your entities are, and it needs your entity manager for that. So it's in the README, so you can check it out.
Thank you.
And if
it
still does not work for you, then please open an issue.
Okay, cheers. Thank you. Yeah, thank you. Thank you very much.
Sorry, it's not probably question, but side information. But you did not tell anything about result cache that is implemented, and in terms of extensions, it's really interesting stuff, because we have you already know it. But
I know you opened a bug report about this.
Yes,
you said that I'm not talking about result cache, but I could talk about PHPStan all day. So of course I had to omit some stuff.
I would like to warn people because the extension for the Symfony is really great, but there are scenarios when result cache is not invalidated, so it can report invalid results. But it's not a big deal, but you need to know it. Thanks.
You can also tell people about all the other bug reports that you opened.
Oh, hi, hello. Thank you for the beautiful presentation and explanation for all the rules. And since I installed the PHPStan for the first time, I had like one question. It's like not very technical. It's like just by the way, it's opinionated, but why are you using the neon extension, not some kind of a YAML notation or something?
Because 8 years ago I was young and I made some mistakes. But I can give you the technical explanation. So in the Czech Republic there's a popular MVC framework, and it's only popular in the Czech Republic, called Nete. I don't know if you heard about it, and I was a really heavy user of it. And before PHPStan, I was like the most active user on the forums, helping other people. So I really like it. And in the beginning, it helped me to speed up the time of development a lot, because the neon file extension is there because PHPStan still uses NetDI, which is it's a DI container. It's for assembling objects and auto-wiring. So with a little bit of configuration, you can do a lot of things. And neon is basically like YAML. So in practice, there aren't really many problems with it. And even after 8 years, it's still in there. And in practice, it works mostly fine. And it's really powerful. And in the end, all the configuration files, including the configurations that is in PHPStan itself and your own project configuration, are all merged together. So if you know what you're doing, you can actually override a lot of stuff from PHPStan thanks to this architecture. But of course, if I was starting today, I would choose something different and spend a little bit more time choosing what's going to be used in the project.
Oh, perfect. Thank you.
Okay, that's it. So please, if you want stickers, you can go grab them at the stage, and thank you very much.